Following on from the survey of the 30 men's heights and weights, find the equation for the least squares regression line, weight equals b times height plus a, and plot, and b construct the residual plot. So we have to calculate b first. B equals r sy on sx. Now remembering the values were already calculated from the part 1 of this video. So we've got b is equal to 0.72 times sy, which is 8.32, divided by sx, which is 10.51. So b is equal to 0.57. Now we can calculate a. A is equal to y bar minus bx bar. So that's the mean of the weight minus b times the mean of the height. Now remembering we calculated x bar, the mean height, and y bar, the mean weight, in part 1 of the video. So a is equal to 81.64 minus 0.57 times 187.71, and that equals negative 25.35. So the equation for the regression line is weight is equal to 0.57, that's the gradient, times height, minus 25.35. We're going to go ahead and plot this regression line equation, but we've got to be careful because of the scale we've used. So we've actually started, the y-intercept is shown in the scale for height of 160. So we're going to sub in a height of 160 to find what w will be. So for h equals 160, w is equal to 0.57 times 160 minus 25.35, and that equals 65.9 kilograms. So 160.65.9 is a point on this graph, and that lies about here. Now we only need 2 points on a graph to draw a straight line, so let's just choose for height equals 200. So for height equals 200, w equals 0.57 times 200 minus 25.35. So w equals 88.7. So 288.7 is a point on the regression line. So that's approximately here. And then finally drawing in the regression line, that gives you the more accurate fit for these data points. Okay, now we've got to work out the predicted values of kilograms if we used the regression line to predict it, knowing the height, what the weight should be, and we put it there. And then we work out the residual, which is what we measured minus the predicted value. So I'm just going to do a few. For h equals 170, w equals 0.57 times 170 minus 25.35 equals 71.55. So that goes in here, and the residual is 13.45. Let's do the next one. H equals 182. W equals 0.57 times 182 minus 25.35 equals 78.39. And the residual is 79 minus 78.39, which is 0.61. So go ahead and use that same procedure, going through each of the heights and finding the predicted value and the residual value, and I'm just going to go ahead and work all that out. Okay, so that's our completed table of predicted values in accordance with the equation for each of the heights, and the residuals, which is the actual measured weights minus the predicted weights. So now we do a graph with the height still on the x-axis and the residuals on the y-axis, and they are either side of 0, the point 0 being the actual predicted value. Okay, so we're going to go through and we're going to graph height against residual. So the first point is 170 and 13.45, then 182 and 0.61, 186 and 8.33, 192 and 0.91, 196 and negative 0.37. And I'm just going to go ahead and keep working down the chart, graphing height against the residual until it's complete. So this is what the residual plot looks like. Now, because the dots are scattered randomly and there's no distinct pattern, we can say with some confidence that weight increases linearly with height.